Wow, this is awesome, guys. I want to thank everyone for coming to Builder Faire 2013. It's our first Builder Faire at Code Camp, and turnout's been fantastic. We've had some really great sessions, and we got really great sessions to come too. So thank you guys for coming, and this is a Kinect lab. So unfortunately, not everybody's going to be able to participate in the lab, but the first half of it's going to be a talk, and then we'll do a lab, and everyone can kind of look at the code and kind of learn like how to do it. But not everyone's going to participate because we only have enough for like 7 people. I'm going to talk about the Internet of Things, and there's a big movement today about how more and more devices are out there that are invented to enhance our lives. So why wait for someone else to build something? If there's something you want, the do-it-yourself movement's out. People are building things, and we're doing some fun things at home building things too. So 3D printing, people are building things with printers, and Internet of Things is on its, whoops. So the Internet of Things, people are connecting all these devices to the Internet. And like at night, I'd love to have all these sensors on my body that can detect me if I'm sleeping or sleeping badly, so that I can look at the reports in the morning and find out the fan was bothering me or something like that. So with the Internet of Things, it's getting cheaper and cheaper to build these sensors, and you can put them anywhere. They're small and fun. So people are building some really cool stuff. One thing, I don't know if you guys all noticed the air swimmers outside. But we came up with this idea 2 weeks ago, and if you scan the QR code on the fish, it'll load an app on your phone, and you can tilt your phone to make the fish swim in the air. So they have fins on the back, and you tilt your phone left or right, and the fish will kind of wiggle for you to make it go certain places. So next year we'll put a camera on it, and I'm kind of excited too because I want to put a camera on it and put it in the house so I can be in the office and kind of swim it around the house and see what people are up to. Be kind of fun. So you can leverage your .NET skills to connect with the physical world. And I've done a lot of projects, and I'll show a couple of videos. But this lab is going to be around one of the projects I did early on. It's a squirt gun for my pool. And I'm going to stand in front of the Kinect and kind of demo what it'll be. But you see over here on the servo, it's mimicking my movements. So that's what we're going to do in the lab. We're going to build that. And it's really not much code, but I'll show you how to use the Kinect code, and we'll talk to the Netduino microcontrollers to build that. Done some other really fun projects at the house. The garden is on a timer, so it remembers to water it, or you can get out your phone and water the garden. And the best part is you don't have to remember to turn it off. It'll turn it off for you. And let me show a video of the squirt gun. Hello, this is Dan Faire from Logical Advantage, and today I'm going to demo my squirt gun. The squirt gun is controlled by a Netduino microcontroller that's actually inside the house. There's a control panel here, and when I push these buttons, the Netduino tells the servo to do certain things. This program just runs around the edge of the pool. And I'll run another program, and now if you could focus a little bit on the servos itself. So the Netduino is telling the servos where to go. And one of the other really cool features of this is over here is a garden, and I can turn the water on in the garden by pushing the button. But also, I wrote a program on the Netduino that during certain times in the day, it'll run the garden for half an hour and then turn off. Okay, I'm going to go upstairs and show you the really cool stuff, but before I do, I'm going to play a game of jump rope with the Netduino.
So upstairs, Dad has a Kinect. The Kinect is wired to a computer and to a Netduino. He wrote a code for the Netduino so that he can control the squirt gun. with his right hand while using his left hand to turn it on and off. To turn it off, he straightens his arm, and to turn it up, he bends it, quite simply. I got squirted.
And there you have it. A car came by when I was doing that, and I got distracted. My hand kind of went a little bit over and sprayed him really good. So it's fun to be able to nail kids with this. And I've got my other son, Max, here, and he actually helped a lot with this lab. He built all these servos, and he cut all the wire for the lab and did all that stuff. So I wouldn't have been able to finish in time without his help. So yeah, thank you, Max. And the other cool thing is Adam, our neighbor, he spent the night, and instead of the kids playing video games, I snuck up on them. They were putting together servos. I was like, how cool is that? They're like doing stuff for Code Camp. That was awesome.
What'd you pay them?
Not enough. Yeah. When actually, I wanted to have an LED in here to simulate the squirt gun firing, but I didn't pay him enough for that. Maybe next year. Okay, so one of the other fun projects I did is a QR code that in the fireplace we put the QR code, and you can scan it with any smartphone. And in the back of the house is a web server and a Netduino that turns on the solenoid, turns on the gas to burn the code. So it's a self-destructing QR code, kind of a fun Internet of Things project. And when doing this, we use technologies such as HTML5, jQuery mobile, things that work on all devices, because everyone in the house has a different device. A lot of them are iOS and Android or Windows phones. So when we use this kind of technology, it works for everybody. I don't have to write a native app for everything, including those air swimmers outside. It's using JavaScript to know the tilt functions to let the air swimmers work. One of the other cool projects, and I'll show a video on this, was Halloween. We did Halloween right this year. We used a Kinect, and as the kids walked by, I'll show in the video, but the ghost in the coffin will turn its head and follow the people as they walk by, and other ghosts on the ground kind of react. So let me show you what that is all about. Hi, I'm Dan Faire, CTO of Logical Advantage. This Halloween I've been having a blast with my monsters. This ghost jumps up to the gravestone, and there's this cool zombie on the ground that he rubs the ground. But the really cool part of this is the ghost in the coffin. Watch what happens as I move around. So I go up and down and he follows me. So he knows where I am, and he tracks me. The other part that's really cool for the kids is if you look on the screen, the kids can do their funky Halloween dancing, which is really fun. And for an extra treat, I made a website. And when the kids ask me for candy, I can easily say no, which gives it the no. But if they're really sweet kids, then I'll click on the yes button. And I'll click on the scare button to do a scary scene. To make all this stuff work, I'm using the .NET Micro Framework, a Kinect to do the body motions, and MVC for the mobile website using HTML5 and jQuery mobile. I'm Dan Faire, CTO of Logical Advantage, and there you have it. So one of the funny stories on Halloween is I spent so much time making this contraption for Halloween. My wife's like, "You're not going to spoil Christmas like you did Halloween this year." So yeah, I'm saving my marriage, and I didn't do Christmas, and maybe next year, I don't know, but we'll see.
Make a Santa that watches you.
Yeah, Santa can watch you. So I spent a lot of time on the skull. There's LEDs that light up in the eyes, and one of these exact kits that looks just like this. There's Velcro on the top, and I just Velcroed it to the top of the coffin. So I used the same code I used for the squirt gun for the Halloween project. And you know, I'm using .NET, so I made a servo class, and from that servo class, I made another class that's a pan tilt, and then I have a class that's the Halloween skull and another class for the squirt gun. So all this code was reusable and leveraged, and it saved me a lot of time. So for Halloween, like, I probably spent 30 hours, and probably half of that time was getting the coffin to work and all the devices to go. So that was kind of a fun thing. But the other thing that's really cool about this is it didn't really cost very much money at all. The Netduino is only $60, and LEDs are a couple dollars, and like 20 some dollars for the servos. So you can build things really cheap that are really fun and cool. So the next lab, there's a session talking about the lab that Mike Lennon back there is doing it, and I highly recommend everyone to come to it because it's amazing and it's really awesome. And also I want to thank Mike for helping me set up all the stuff. I never would have gotten set up without him, so I really appreciate all the help. So we got three main components in our lab. We have a Kinect, and there's two types of Kinects. There's a Kinect for Xbox and a Kinect for Windows. And in this lab, we're using the cheap Kinect, the Kinect for Xbox. And these are the exact same Kinects that you use in an Xbox. If you get the newer Xbox, then it doesn't ship with the power supply that you need to plug it into a PC. But if you buy a Kinect separately, it comes with the power supply that has a USB cord that you can plug into a PC. So you'll need a power supply if you have a new Xbox that shipped with a Kinect. But all these Kinects that you see out here are ones that we borrowed from people. So thank everyone for bringing their Kinects and making this day happen. And we've got the servos, and I'm going to talk a little bit more. I got some slides on the Netduino. So the Netduino is awesome. It runs the .NET micro framework. You code in Visual Studio. You can write C#, and if you need to, you can write Visual Basic. It's event-based programming, and the best part about it that's really different from the Arduino is you can debug your code. You can put breakpoints in your code and see what the values are of everything, which is really helpful and makes things go really smoothly. The Netduino comes in tons of shapes and sizes, and I didn't even put all the different pictures in it, but there's a mini one. There's one that can't go on the Ethernet, which is almost a waste of money. Because everything fun needs to talk to things, and this is an Internet of Things talk, so don't buy that one. But all the other ones are awesome. There's the Netduino Go for those people who are afraid of cutting wire. You can plug in things, and they already have all these kits made that plug into it. Like you could buy a servo kit and just plug it in and start coding if you don't want to cut wire. But as you're going to see in this lab, I have the wire already cut. It's really not a big deal to make your own circuits. So have fun. You may as well solder. You may as well cut and do some real, I don't want to say real work because it's real no matter what, but it's a lot cooler, I think, if you use the Netduino Plus and build your own circuits. This is a Plus 2 also. Okay, so for the lab, if you're running a Netduino, and actually you guys don't need this on the lab because we're talking over the network to the devices, but in order to use the Netduino, you need to install some software, the .NET Micro Framework SDK, and there's the Netduino SDK, and all this stuff, you just go to the Netduino website and download it. It's real easy. The Kinect's moving around. All right, so the Kinect is a great device. It has tons of sensors in it. It's got a tilt motor that you can tilt it around, an IR emitter, and I brought some infrared glasses. I don't know how it works with the lights on, but it's spraying this whole room with infrared dots that it uses to measure depth. And I'll pass this around, and I don't know if you can see it or not, but with the lights on, see if you can see the dots. You can kind of see how the Kinect is working to know how the depth perception works. But it's got a whole microphone array that it uses, and it can kind of try to figure out where people are based on sound and things like that too. It's a really amazing device, and the really cool thing about it is I don't know much about the device, and I haven't really spent much time with it, but it's been so easy to build the stuff that I've built with it that anyone can pick it up and learn. And the other part that's really cool about it is there's great sample code out there, so you can download some sample code and just start tweaking it. And that's the way hackers are made. You just download code and play with it and make it better. And that's kind of what we did in this lab. We started with one of the samples and updated the sample to get it to control the servos. Okay, now it's time for the fun part. We're going to do this lab, and only the people sitting at computers can do it, and only 7 of us can do it. And actually, I'm going to take this one for my demo one. But I'll need groups to come up and get the Netduinos, and we can put together the circuit for it. So I think it would probably be best, too, if we put 3 or 4 people in a group. And some people aren't going to be able to participate, but you can at least look at the code, and I think you'll still learn and get stuff out of it. So why don't you guys form groups of 3, and then come up and get some Netduinos. This is all we need to do, okay? You take the red wire and put the red wire on the pin that's labeled on the Netduino as 5 volts. So raise your hand when you have the red wire on the pin that says 5 volts. The single in, yeah. Put the single in and the pin that says 5 volts. Good, thank you.
So it's labeled 5, right?
Yeah. Okay.
You should do groups of 4, that way, like, all the rows are blue.
Oh yeah, we should have done that. Yeah. Okay, does anyone not have the red wire and the pin that says 5V on the Netduino? No. Okay. Now take the other end of the red, and I forgot to tell everyone, you're going to need one of these. So everyone get one of these. So on the servos, you'll note there's 3 wires. One's black, one's red, and one's yellow. So the red is power, the black is ground. So match the red wire with the red wire and the black wire with the black wire. All right, so here's what we got. Let's start with the red. The red makes a V. So you put the red wire, the 5 volts down, and then there's 2 reds that come up. Attach those 2 reds into the 2 red wires on the servo cables, on both of them. Does that make sense? And then do the same thing with the black. Put the black on the ground.
There's 2 grounds. Which ground?
It doesn't matter. Either ground. Ground is ground. So does everyone have the red and the black wires all connected into the servos? Sweet. We'll take a little bit more time.
It is 6 and 9, right?
Yeah. 6 for the top. Ah, good. All right. Do you guys got it? Sweet. Okay, now we're going to take care of the yellow wires. So what we have 2 green wires. All right, so one goes to pin 6. Attach that to the yellow wire on the top servo. Did you get it? And then do the same thing with pin 9. Attach that to the bottom servo. Yeah, thanks. Did you get it? Sweet. You guys are quick learners. Okay, so what we have is the red wire is power, the black wire is ground, the yellow wire is the signal. So there's a pulse width modulator on the Netduino. When it's half up and half down like this, then the servo will be at 90 degrees. When it's something more like this, the servo will be at 30 degrees. So the Netduino is smart enough to change the pulses to tell the servo what position to go to. And the great thing is I wrote the code that's a servo class that does all this stuff for you, uses the pulse width modulator. So all you have to do is tell the Netduino what angle do you want to make it, and a method that we're going to use in the lab, and the servo will go to that angle. Okay, now the next thing we're going to do is open the lab, which is in this folder. It's in C Netduino. And then the lab is called Kinect Gun. Yeah, open that up in Visual Studio.
So the ones with duct tape all have connects connected to them, the others don't.
Open up the main window, the code behind for it. Mainwindow.cs.
Wait, it's mainwindow.x.
It's fine. It's just the code behind for the main window.
All right. And scroll to the top. The first thing we're going to have to do is configure the Netduino that we're going to talk to. And we're doing this by the IP address. So each one of these Netduinos has a different IP address that it's talking to over the network. Just replace the IP address with the IP address that's on the sticky note.
So IP address comes with the device when you buy it?
No, I programmed them into the device already.
So if we buy, how to do that?
You can do static, you can do dynamic, DHCP. So for this lab, I did static so we could assign each one a different one.
When the device is fresh, how do you connect to it? Is it
Yeah, when the device is fresh, it has nothing on it. So like the Ethernet stuff, I had to write that. So I wrote a class that does.
put it on an SD card and to load it to the device?
No, you actually deploy it through Visual Studio. So you plug it in through the micro USB, and you can deploy it through that. I've already downloaded the code for the Netduinos.
This is the first one, right?
Yeah,
You
there's.
said through micro SD, we have to connect to the computer and run it with Visual Studio, right? So what kind of project do we need to do?
Yeah, it's the .NET Micro Framework project, and you deploy code through the micro USB.
Okay. It's a default code, okay.
Yeah. So you can debug it and deploy all through the micro USB.
You can get all these things from the website.
From what?
You can get this all from the website.
Netduino website. Not this code, but I'll show you some links at the end that have things for it. Okay, does everyone have the IP address in? Okay. Let me jump to the next slide. Okay, now we're going to put some strategic code in there, and this is a sample that I downloaded from the Kinect website. Yes, you guys have a question? Oh, no, I'm sorry. This is a code that I downloaded from the Kinect website, and all we have to do is put our method in the right place. And if you scroll down into the middle, you'll see where there's a for each, and it loops through all the skeleton in the skeletons collection. So with a Kinect, you can have up to 4 skeletons, but it can only show 2 at a time. And you can see if it's one of the tracking skeletons, then it's going to draw the ones that are tracked. So you could, if you walk into the Kinect mode and then walk out, you'll be a skeleton. You just won't be one of the tracked ones. And so this will be just detect the tracked skeletons. And I already put this code in there for you. But one thing that I'm doing is there's a counter. The Kinect has a fast frame rate, and it can send signals over the, we're talking over the network to the Netduinos too fast. And so what I did was I put a sample frame count. So it's only going to move the gun after a certain number of samples. I think I put in 10 or something like that, because the Kinect just will talk too fast and it can't keep up. And if you have a Netduino plus 2, then it's a little bit faster, and you can move the sampling down. So everyone go to the move gun method. Is everyone at this method? So what we're going to do is we're going to now, we're going to, actually before we get this, I need to plug in all the Kinects back. So let's plug in, bring back your Netduinos and your servos, and we'll plug them back in over here. Thank you. Okay. Some people kept their IP addresses, so I'm not going to know which one is going to control. Cool, thank you. Thank you. This one needs power. Yeah, thank you. Okay. I think I should test, let's test them all out first. You think we should turn power off on them, or just test them?
I'd test one of them and see if it works. If it doesn't, just reset all of them.
Okay. Unplug it and see if it goes through its right now. Okay, I wrote this tester app, and what this tester app does is you can enter in your IP address and send a message to the Netduino. So we plugged in all the Netduinos we need to test to make sure that we're talking on the network. The Netduinos are kind of fussy, and they sometimes take a little bit of hand-holding and resetting to get them to work right. So usually if there's something not working right, it's the Ethernet communication. And so it's always a good thing to test first. And so that's what I'm going to do next. So 200 was the IP address of the one I did earlier for myself. I'm going to try 201. Send it a command, tell it to move to 10 degrees by 10 degrees. And that one didn't work. So which one's 201? This one. You reset it. I'm going to open up DOS window and see if I can ping it.
Could be us. We may have done wrong cable connection.
Now you're good. Just doing a simple ping test to see if we can talk to it, and it's not talking. Did it just do a jig? Still unreachable. Unplug it for maybe a little bit longer.
We don't have enough wires up here.
Yeah. So if you ever seen spaghetti code, this is spaghetti wires. I mean, they're everywhere. Let me try pinging some of the others.
206.
Yeah, 206 is talking.
Try 204.
204 is good.
Try 202.
202 is good.
And 205.
205 is not good.
Try 205 again.
So when you're playing with Netduinos, you're playing with network settings a lot to get them to work right. So this looks like it's something that's not going well, but this is actually going great.
So we need to hook up 203. I'll hook that up.
Is 203 not plugged in? And 206 doesn't work.
206 I think was working,
Are they all working?
except for 201.
Okay. Did you try resetting 201 already?
Yeah, we've tried it a couple times.
Okay.
Let's try. Try 203.
I think I might know what the problem is. Let me test one thing real fast. 203?
Yep. Something happened with 203. Somebody's moving something.
I did that.
Small victories. Small victories.
One step at a time. Baby steps.
Okay, Nip. So it's the 201 that's not good?
Yeah.
Which group is 201? Sorry, guys. We'll work on you after the session. Everyone else will proceed with the lab.
This was a test, only a test.
Yeah. Okay. Actually. Okay, so what we're going to do is we're going to debug the pan first. And I loaded this code in the move gun method, and we're going to play with this method until we get it controlling the servos. And one thing I think is really good with the Kinect is don't go by coordinates of like your hand. go by coordinates relative to another joint. So the shoulder relative to your hand. Because when you step in here, you don't want this to think that the servo is way on the left side just because your hand's there. It needs to be relative to, it's actually moving, to where you are. So what I want everyone to do is run the Kinect app, and you notice that there's a message, and in that message is the information we're going to use to figure out what the limits are from as far left and as far right as you can be. So load the Kinect and step back from the Kinect, because if you're too close to it, it won't register you. You may need to get a little further back. Is it working? There's so many skeletons in the room. So is it working for some people? What is it? Yeah, sure. Who's that?
So you can see all of that.
Yeah, it's pretty amazing. Yeah. From someone in the office.
Oh, really?
Yeah.
People in the office have extra. They're not getting everything for you.
So, one thing I should have done is there's two people and there's two skeletons, and it's probably displaying data from both of them. And what we really need to do is only see it from one skeleton. Yeah, so if you're in the view and you shouldn't be, try to get one person in the Kinect range. Take your hand and go all the way to one side and see what the number is. With just one hand. Or yeah, I don't care if you want to do left or right. We're amphibious. So does anyone have a value for the difference between the shoulder and the hand on the x coordinate? 0.42? Okay. And take it to the other extreme. The same hand. So what'd you get? No, we're doing the x-axis. So when you're doing this, it's best to do one axis at a time. If you try to do two axes, you'll get confused. .14? Are you using use your right hand? Oh, your other right hand. Okay, so she's getting, and what's it the other way? Go like this. Yeah. Okay, so she's getting negative 0.2 to 0.45. So what we're going to want to do is translate this into an angle. So when her hand is all the way, was it this one? It was, yeah, when it's this way, it was the 0.45, and this way the negative 0.2. So what we're going to do is you're going to have to add to it to make this go to 0. So we'll add 0.2 to both of them. So that'll make that 0 and this 0.65. We want this to be 0 degrees, and 0.65 times x equals 180 degrees. There's no way to get out of doing math when you're doing the Kinect. So you do a little bit of math, and x equals some value. Let's say it's like 250. I have no idea. What's that? 276? Okay. 276. So that's the value that I used to do that math we just talked about. And in my sample, it was 200. And now, update our text message. That instead of showing the floating point difference between the hand X, show the angle. So if you put in code like this, for yours it was 0.2 because you're smaller than me, or your arm's not as long. And then times whatever the factor was. For your factor was 276. And you can just use mine too if you didn't actually do the math yourself.
Something will move.
Yeah, it'll move. So open up the Kinect again and test to see if you're getting an angle change as you move your hand. Do you have a question? Okay, cool.
So what we need to do here?
Yeah, so what we're doing is we're taking the floating point result we got and converting that into an angle. And
We have 200.
Do we need to change
oh,
this?
okay, so that's perfect. Run this code. Wait, no. Put in, okay, convert that to an int32.
32.
See where it's on the screen there? There you go.
And we have to add
Yeah, add 0.5.
to 200 was like,
Yeah, and multiply by 200
yeah, it was entered.
is what?
We did
Minus 0.48 to 0.47, so total of 0.4.
Okay, you got longer arms than she had. Oh, okay, cool. Probably because she's further back, maybe. I don't know.
further back. That's it.
Yeah.
This is 0.5, what is this?
0.5, yeah. Close paren, times 200, close paren. That should be good.
So run that and see if you get just an angle change as you move your x-axis.
A lot of customers.
She got 175, 8,
175, sweet, and move your hand this way.
18.
18, close enough. It should be 0 to 180. So you guys are awesome. What's your angle look like? What's your angle look good? Sweet. All right. So what's important to do is only worry about one axis at a time when you're doing something that's with multiple axes. For us, we're not paying attention to the z-axis, the depth. We're only paying attention to the x and the y, the up and the down. And it's best to not get too confused, because if you try to do two at once, you'll get lost. But one, it's easy. And I keep thinking people are raising their hand, but they're playing with the Kinect. Yeah. What's that? 15 more minutes? Sweet. All right. So now we're going to cheat. Normally what we would do is we do the same thing for the y coordinate. But what you guys can do is just copy your code and replace x with y and just pretend like it's the same range, as it'll make the servos move. And your final code should look like this. I actually commented out the code and put it below the method. You guys can copy it in there if you want to and uncomment it.
And why we didn't get a why. Why was servo class in there?
Yeah, it's talking over the Ethernet, and the servo class actually running on the Netduino on the microcontroller.
Oh, okay.
So, yeah, just setting the angle. So what this code is doing, this is actually the coolest method right here, because this is a singleton, so it grabs the instance and it sends a message, and that message is the angle. So someone is doing it. Who's this one? 205. Yeah, you guys rock. Yeah, you guys do rock. So we got several of them moving now. Yeah, they're sword fighting. Are they facing the wrong direction? Should I flip them around? 204.
Ours is up front right here.
Yeah. Yep, 204s. Yep, someone's moving 204. This is like happiness to me, watching all these things move. Pretty awesome. You just move one hand.
I thought this one was, but it's 202.
I think,
I'm assuming this
no, that's 202. Yeah, I bet you that's 203. Is yours not going? What number are you? I'll see if I can talk to 202. It's blinking. It's not plugged up. Oh. Yeah, it's not talking to 202.
Resetting?
Yeah, reset.
Try it again.
Yeah, 202 is talking now.
Try it again.
It's this one. No. Oh, it just did something. It's your factor, I think. It's smaller. Let me see it.
Maybe.
Oh, it's not even picking you up.
Not really.
That's showing that there's network problem.
Yeah, it's like lagging.
Yeah. Oops, picked up someone else. Yeah, I can post this code. Oh, that's a good point. Let me jump to my slide. So I've got all kinds of code out there that you guys can look that do all this stuff. On the code project, there's home automation with Netduino and Kinect. It's the exact code that I used for the swimming pool. And the jQuery mobile code is up there. And I've been featured on Coding for Fun with Microsoft Channel 9 a whole bunch of times. So you can peruse their sites and see lots of videos. And if you go to YouTube, I've got a dozen or so videos on there. And the code project sites have been pretty popular. Last year, I think I had, if you sum up all the visits from the different ones, like 250,000 views on them. That's pretty cool. This is the servos, I got it from Robot City, and they're $20-some for the whole pan tilt kit. And it's amazing that you can get a cheap servo like that to control a hose, and it really sprays far and good. So, yeah, it's really amazing. Any questions? But thank you guys for coming. And also, right after this is a really, really cool lab with 12 Netduinos all talking to each other with Azure. And each lab, each group has a different lab, and they're all building part of a security system with Mike Lennon. So I highly recommend everyone to come to that talk.